Next topic is of block diagram representation. Whatever learn the equations what we done in the previously, it's a different method. Again, one more method. In the first way, by using of your convolution operation, we will be finding of what is our LTI system. Next, we go on with the differential and difference equation. That is the second method, and this is the third method to find out what is the input-output relation. Okay. The next is of block diagram representation. What is the meaning? Block diagram representation is the pictorial representation which describes the different set of internal components. What is the internally? It is connected internal components used to determine the output from the input. This is the meaning of the block diagram representation. Why it is needed? Block diagram representation has a great significance because of it will be helping in the implementation of the system where you are going to using your computers. A small example here it is given. The block diagram representation for a continuous time system. Continuous time systems means if you are using your CROs, if you want to check what is the input you given, what is the output you will be getting, right? Continuous signal it will be displaying there, right? In such applications, continuous time system is the basis for an analog computer simulation of the systems, and it can be directly translated into a programs. Means just in the system what it is going for, this is one example, or else in when you come for your MATLAB versions you will be coming under, you are just giving a block and you will be giving the input and you will be getting from the input you will be getting the output, the operation what it is going for inside, right? That is our system. That operation what's it's taken in the hardware part, but that hardware is going to be converted to the program. Okay, in such applications this will be using for, this is very important. Okay, translate into a program for the simulation of such a system in the digital computers. In such applications we are going to use our block diagram representation. Okay, then representation suggests a simple and efficient ways to implement systems using the digital computers. This is about the introduction. Next, we will go with the small theory based on the block diagram. What are all the elements we require, how it is going to be drawn, what are all the methods are there we can follow to solve the problems. Those we will run one by one. Okay. For a discrete time system, it is having three elementary operations on signals. That is, the first one is of scalar multiplication, that is x of n. It is represented as x of n. The scaling factor is of a. We have to show by an arrow like this. You will be getting the output, that is y of n. The output is nothing but a into x of n. This is one elementary signal. Then the second one is of addition. Addition means we are going to use of the summation symbol here. Input is given to give as x of n. Output you will be getting as z of n here. And here one more signal, that is y of n. X of n and y of n are the two inputs for the summation. Okay, this is the summation and you will be getting the output z of n, that is equals to x of n plus y of n. And summation, it can also be represented as plus. In a circle you can write as a plus, or else in a circle you can use of the summation symbol. These are two methods we can use to do the operation for the addition. Next, third one is the time shift. It's going to be represented in a box, a small delay that we called as a S. Here it is taken. Okay, the input is of x of n and output is of y of n. That is going to be equal to x of n minus 1. How many delays are going for? It depends on. If I am writing only one s means n minus 1. If I write one more s means, if I write one more s like this in a cascade manner, then it will be x of n minus 2. 2 times it is delayed. N minus 1 means it's delayed by 1 position. Okay. And the instead of writing as s, we can write as d also. Okay. S is nothing but shift operation. D is nothing but delay operation. Shift or delay in the signals and system, it will be same. It will be same. Okay. In your different processor controller, if you are going for, you will be using of some other methods, shifting operation and all. Here, if I am using of D or else S, it will be delaying with some time interval. Okay. Then S is the, okay, then here a small block diagram is given for the discrete time signal, that is x of n is the input. Here b naught is taken with the scaling factor b naught. It is going to be added, and our x of n signal is delayed by or else shifted by one position, that is s. One s here it is written. Then again it's scaled by b1. Again it's delayed, shifted by 2 position. Again one more s with the scaling factor b1. And next, after 2 delays, again a scaling factor, here it is taken as b2. After third shift, we are shifting for the x of n only. Okay. Then you will be getting the coefficient value, that is or else the scaling factor is here of b3, and all these are going to be added, and it's given for the this summation. Okay. The output what I am going to get after this whole operation is taken as z of n. This z of n again given for the one more summation. In this case, the output is going to be shifted or else delayed by one more 2 times. Here first, if it is going for first delay, then with the coefficient of minus a1 it's going to be taking, and with the second delay it is going to be taken as minus a2. And again this whole delay with and coefficient or else your scaling factor, it's going to be adding, then you will be getting your output, that is y of n. How to write the equation for this? First we'll write how to write the equation for this. From equation, how to draw the block diagram. What I can write, what is our z of n? First we'll find what is our z of n. Here that z of n is equals to x of n is directly taken. Observe here, it is x of n is directly taken. So x of n b naught, b naught into x of n plus, again what is the next scaling factor is of b1 x of n minus 1, because it is shifted or delayed by 1 unit. Okay. So b1 x of n minus 1, then b2, how many times delay? It's 2 times. For that reason b2 x of n minus 2 plus b3 x of 3 delays means n minus 3. In the same way, this is for intermediate signal, that is z of n we got. Then similarly the output y of n, it's going to be taken as z of n, signal z of n minus, because here it is a minus sign, right, minus a1 y of n minus 1, because it's delayed or shifted by 1 minute. Then minus a2 delayed by 2 times. So y of n minus 2, we will be getting this equation. Then what you have to do, just writing what is our y of n. I am substituting the z of n from this equation. I am substituting here. So if we substitute, we will be getting as y of n is equals to b naught. Same thing you write here. Okay. Instead of z of n, I am writing this equation, whole equation. b naught x1 plus b1 x of n minus 1 plus b2 x of n minus 2 plus b3 x of n minus 3 minus a1 y of n minus 1 minus a2 y of n minus 2 will be getting off. Then what I am doing, I am just doing what, wherever our y terms are there, I am keeping those in a one side and x of terms in the another side. Here y of terms in x of terms in the RHS. Okay, just if I keep like that, you will be getting as y of n plus a1 y of n minus 1 plus a2 y of n minus 2 is equal to, means shifting of these two units this side. That's it. Then remaining part you write as it is, that is b naught x of n plus b1 x of n minus 1 plus b2 x of n minus 2 plus b3 x of n minus 3 you have to write. This is the equation. Then for continuous time system, the general form of a differential equation is going to be taken as summation k is equal to 0 to n ak dk y of t divided by d tk, that is equals to summation k is equal to 0 to m bk d k x of t divided by dt of k if n is greater than or equals to m by integrating equation n times. If I do, I'll be getting as summation k is equal to 0 to n ak y of n minus k t, that is equals to summation k is equal to 0 to m bk x of x power n minus k of t. For a second order system, if n is equal to 2 with a2 is equals to 1, based on this the equation is going to be y of t is equals to minus a1 y of y power 1 of t minus a naught y power 2 of t plus b2 x of t plus b1, substituting the values here, that's it, plus b2 x of t plus b1 x power 1 of t plus b0 x power 2 of t. It's going on where what is our y m of t is the m fold integral of y of t, then y power 2 of t means 2 folds, for 2 fold integral of y of t, x1 of t means 1 fold integral of x of t. It's going on like this. Here direct form 1 representation is going to be as x of t is, here observe, here you will have to remember this is very important, direct form 1 and direct form 2 representation. Okay, x of t b2 with the, here instead of going to use as a srd we are going to use of the integration symbol for the continuous time. Okay, here it is of b2, after integration here it is going to be b1, here you have to represent how many times it's integrated, one time x1 of t, then here it is of x2 of t, two delays, that is b2 b1 b0. Here in the same way output y of t it's delayed by 1 means a1 you have to write here, here minus a2, here you can write of y dash of t and y2 of t here. This is direct form 1. Direct form 2, instead of going for how many delay functions are there here, integration functions 1 2 3 4, instead of going for 4 integration function we can reduce to 2. How it is reduced, you observe here, x of t summation, instead of writing summation here it is shifted to this side where I am combining these two integral functions. That is, if I combine, instead of going for 4 I can use of 2 integral functions. X of t, here it's going to be a1 minus a1, then minus a2 a naught, then here it will be b2, I missed here writing, your b2, then b1 b0. You have to remember these two forms. direct form 1 and direct form 2, how it is written. Okay. Next, this is in terms of a continuous. In terms of your discrete, how it is going for, you'll be seeing of that now. Their block diagram representation is not a unique one. Okay, you can design how you want. Since the convolution is associated, consider two systems having the impulse response h1 of n and h2 of n are connected in cascade form. The order can be interchanged. The order can be interchanged without changing the input-output relation of the system. Observe here, this x of n signal summation. With this diagram you just go through. Instead of taking here, I'm just what I'm interchanging these two. Okay, interchanged fully. Minus a1, minus a2, b0, b1, b2, b3. This is what the form we call as this as a direct form 1. Then consider the signal at point A. This is at point A is a of n. Therefore, the signal at point B and C, where it is, here it is B and here it is C, are a of n minus 1. But the same signal a of n minus 1 at point B and C are obtained by two separate time shift. Here one used, again one more it is used. Instead of going for 2, but it could be obtained by using the single time shift unit. Instead of going to use as a 2, we can use of the 1 only. That's what the meaning here is telling. Okay, if I combine the delay units, instead of going for how many delay units are there in this case, 1, 2, 3, 4, 5. Instead of 5, I can use 3 delay units. Okay, just combining of these 3. Here it is written x of n input. Everything is keeping as it is, minus a1 minus a2 minus a1 minus a2. Here also b0 b1 b2 b3 b0 b1 b2 b3. Just summation here and delay function in between. This form we call as direct form 1 and this is we are calling as direct form 2. Okay, this is for the discrete time and this diagram is for the continuous time. Okay, observe here what is the change between your continuous and discrete. Here minus a1 a0, here minus a1 a2 a0 is not there, it's a reverse order. Okay, here b2 b1 b0, but here it is of b0 1 2 3 it is going on. Okay, therefore the direct form 2 implementation uses less time shift unit RL elements. This is the conclusion we can do from this direct form 2. Okay, now we will solve the problems based on this. Here a problem it is given. Find the difference equation corresponding to the block diagram shown in figure. This is the figure it is given. X of n given, a summation is given. Here two delay functions are given and the scaling factor here it is given as 2. The intermediate signal they only given as z of n. Then the output y of n will be getting. The output is going to be delayed by 1 position and it is scaled by minus 1 by 2 and this is going to be added with the y of output with the 3 delays, right? 1 2 3 delays with the scaling factor 1 by 3 and these are going to be added and you will be getting as output y of n. What you have to do? First find out what is z of n. What is our z of n? That is equal to x of n plus two delay functions. So x of n minus 2 with the scaling factor 2. That's what here it is written. Then what is our y of n? Y of n is going to be equals to z of n. This is the, it's going to be summed, right? Z of n minus 1 by 2 y of n minus 1, correct? Then plus, because here it is of a plus sign, right? Plus 1 by 3. How many times it is delayed? 1 2 3, 3 times y of n minus 3. Next what you have to do, just substitute instead of z of n the equation in terms of x of n. Therefore y of n is equal to x of n plus 2 x of n minus 2 minus 1 by 2 y of n minus 1 plus 1 by 3 y of n minus 3 you will be getting. Then what you have to do? Separate the y terms and x terms. Therefore, you will be getting the equation as y of n plus 1 by 2 y of n minus 1 minus 1 by 3 y of n minus 3 is equal to x of n plus 2 x of n minus 2. You will be getting. This is how you have to do. What is this form we call? This is direct form 1. Right? Okay. Then the next problem is of obtain the difference equation corresponding to the block diagram. The block diagram here it is given. X of n summation, two delay functions are taken. Here it is of a of n and here it is of a n minus 2. Then the output is of y of n and it is again feedback with a scaling factor 1 by 8. Then here it is scaled by 1 by 2 s and it's going to be added. What we have to do? First we will find out what is the intermediate signal, that is a of n. Okay. Then a of n minus 2. What is our y of n? First here it is writing for the a of n. A of n is going to be equals to one input is given as x of n. Then one more is at for the summation. Two signals are going to be added, right? With arrows if you go, you will be getting of that. Then y of n, it is scaled by minus 1 by 8. That is going to be added. You will be getting of your a of n signal. Therefore x of n plus 1 minus 1 by 8 y of n, that is I can write as x of n minus 1 by 8 y of n, right? Then what is our y of n? Y of n is equal to 1, this is 1 by 2 x of n minus 1 because it is delayed by one position, n minus 1 plus this intermediate signal is of these two signals, right? A of n minus 2 y of n 1 by 2 times x of n minus 1 plus a of n minus 2. Then what is our a of n minus 2? In this case, that is x of n signal, it's delayed by, if I not just forgot here that you are not going to use of this summation. If it is not there means x of n is going to be flowing through this. So x of n minus 2, because 2 delays 1 and 2 x of n minus 2 minus 1 by 8. This is this. Okay, now you consider of this minus 1 by 8 y of n signal. Again, how many times it is delayed? 1 time and 2 times, means y of n minus 2 times. Next what you have to do? We have to substitute what is a of n minus 2 in this equation. In the here you have to substitute. If I substitute, what I will get? Y of n is equal to 1 by 2 x of n minus 1 plus x of n minus, substituting this, x of n minus 2 minus 1 by 8 y of n minus 2 you will be getting. Then keep your y terms one side and x terms another side. Therefore y of n plus 1 by 8 y of n minus 2 is equal to 1 by 2 x of n minus 1 plus x of n minus 2 you will be getting. Okay, we will stop here. Few more problems I will continue in the next class.